Hey, Math 1, this is Mr. Roberts at Shasta High School. It's Friday afternoon. I'm sorry, Thursday afternoon. We're taking our test tomorrow, and I wanted to just record a quick walkthrough of the pre-test that we took. Of course, we did this pre-test on Wednesday, discussed it in class on Thursday, and I just wanted to make sure that if you feel like you needed to review some more, listen to some more, watch some more, this was here for you. So the first question here involves an elevator in a high-rise building, and it's moving upward at a constant rate. So I know because it's moving upward, I'm going to assume that I've got a positive rate of change, and it is a constant rate of change, so it's going up at a certain number of feet. The table shows the height of the elevator above the ground floor after various times. So we can see here our independent variable is time, and as time changes, the height of the elevator is changing. And in 1 second, you can see during this first second in time increase, the elevator increased a height of 12 feet, plus 12 feet. So in 1 second time, it went up 12 feet. And then during the next second, you can see another 1 second here, it went up another 12 feet, plus 12 feet. So based on that and the fact that they tell me that it is a constant rate of change, I can see the unit rate of change here. I can see that I am increasing 1 foot, I'm increasing 12 feet per second. 12 feet per second. So this is my rate of change. Now if I want to continue completing this table, at 3 seconds, it's going to be 3 of those 12 feet. 3 times 12 is 36, or I could continue to add, right? So this is going to be 36 feet. The next one doesn't go up by 1. This is increasing by 1.5. I'm going from 3, not to 4, but to 3 to 4.5. So if I think about that, there's 1.5 second in increase. Well, each 1 second of increases is producing 12 feet in height. So a half a second is producing an additional 6 feet in height. So I'm going up here. This time I'm increasing by, because time is increasing by 1.5, my height in this case is increasing by 12 feet plus half of 12 feet, or plus 18 feet. So in this case, I'm going to hit 54 feet. The next one, I am going up by another 1, no, actually it's just a half second this time, right? I'm going from 4.5 to 0.5, so I'm increasing, my time is increasing by a half of a second. And in a half of a second, I produce 6 feet in change, so this is going to go up to 60 feet. Now, the thing that I really like to get to is the function pretty quickly here. And my function is for every unit of time, t, I'm producing 12 feet in height. So my function is just 12t. Now, if I look at that, I can quickly, verify all the numbers that I have here on my table, right? I'll bring the calculator over here. If I turn it on, for example, if I look at 2, right, when t is 2, 2 times 12 is indeed the 24. Whoops. I can do arithmetic too. When I look at 4.5, right, when t is 4.5, that's 12. My function is 12 times t, so 12 times 4.5. And you can see that also produces the 54, right? So these are producing the correct values. This is my function. So let's move down here a little bit. Down below it says, what are the dependent and independent quantities in this problem? Well, I think I discussed it, but to me, and I could probably make the case for another situation, but to me, the height of the elevator depends on how long it is traveling, or the amount of time, how long it is traveling. So I'm seeing the height it's dependent on time. Determine the unit rate of change for this problem situation. We looked at that from the table, and we saw that it is increasing 12 feet per 1 second. Complete the table, write an expression that represents the height for an arbitrary time, t seconds, in the last row. I did that. Very good. The last thing it says, use function notation to determine the height of the elevator at a time of 14 seconds. Well, I didn't write this as a function. Let me do that. And I guess I'll use h here because it's a function of the height of the elevator is a function of the time it's been traveling. And for this, height equals 12 times t, because I'm going up at 12 feet per second. And it says, use function notation to determine the height of the elevator at a time of 14 seconds. So if t is 14 seconds, right, this function will give me the height. So I'm just going to plug in the value 14. So the height at 14 seconds equals 12 times the 14. And if I evaluate that on my calculator, I get that height is 168 feet. So at a time of 14 seconds, right, the elevator will be 168 feet above the ground. Next question says, solve the equation and justify your reasoning. Obviously, class, there's a lot of different things I could do to this equation. Everything I give you is just advice. If you're going to pick something to do, I encourage you to just try it and see if that gets you to what you want. One of the things I like to do is, eliminate parentheses as soon as possible. I can see here that this 5 times the quantity of x plus 4 is trapped inside, the x plus 4 is trapped inside parentheses, so I'm going to liberate that by using the distributive property. I'm going to distribute this multiplication by 5 to both the x and the 4. So this will become 5 times x, and then plus 5 times 4, or 20. And then so that's my portion with the parentheses. And then I'm just going to rewrite the rest of my equation. I have minus 8, and that equals x plus the number 32. 20 minus 8 is 12, so I'll rewrite this as 5x plus 12 equals x plus 32. Now I can see that I've got numbers on both sides of the equation, and I've also got variables on both sides of the equation. So I think what I'm going to do, I didn't know I can pull that up like that. I think I'm going to go ahead and, can I just write in orange now? Here. No, I got to close that dialog box, don't I? So I've got on it. I didn't change anything. I've got these numbers. I need to get them together, and also I need to get my variables together. So I'm going to begin by subtracting 12 from both sides of this equation. When I do that, I'll rewrite it again. 5x is equal to, because 12 minus 12 is 0, equals x plus 32 minus 12 is 20. Now I'm going to subtract, I've got a single x right here, so I'm going to subtract 1x from both sides, right? This is 1x. So I'm going to subtract 1x from this side. On the left-hand side, I have 5x minus 1x, which gives me 4x, and that equals, on the other side, just the number 20. And therefore, x will equal 20 divided by 4 is 5. So x equals the number 5. And if I was to provide reasons for each of these, the first of all I would say would be the distributive property. Oh, whoops, this reason right here, distributive property. The next reason is, I'm just going to say this is arithmetic, right? Or I'm combining some values. I could also say it's the associative property because I'm associating the 20 and the negative 8. I'm going to call it that because I'm associating the 20 and the negative 8 and combining those to get 12. The next thing that I'm doing inside of here is I'm using the subtraction property of equality. Because I am subtracting the number 12 from both sides. And then again, I'm using the subtraction property of equality. Because I am subtracting the value 1x from both sides. And finally, I'm dividing both sides by 4x, so I'm using the division. Now, as convincing as all of that is, it could be the case that I've made a mistake somewhere in here. And at a minimum, I recommend that you grab your calculator and evaluate both the left and the right-hand side of this equation to see that the value of x you obtained really is a solution to the equation. It's only a solution if it makes both sides equal to each other, right? If it makes the equation true. So I'm going to evaluate that. This is going to be 5 times, I'm going to open parentheses, a 5 plus a 4, close parentheses, and I'm going to subtract from that 8. So 5 times the quantity of 5 plus 4 minus 8, and I get 37 for that. So the left-hand side of this equation, the whole left-hand side, is equal to 37. That's what I have here, 37. And the question is the other side 37 also? Well, if I grab my 5, right, because I believe x is 5, and I add 32 to that, I get 37 also. So 37 is the value that makes the left and the right-hand side the same, so it is a solution to this equation. Suppose an elevator stops, whoops, you can't see all that. Suppose an elevator starts at the top floor of a high-rise building at a height of 372 feet. So we're going to start way high at 372 above the ground floor and descends without stopping. It's like an express elevator. It's going to descend all the way without stopping at a constant rate of 15 feet per second. So here's my rate, and it's descending. Write a function that describes the height, h, of the elevator after t seconds. So the height of the elevator in terms of time is equal to, see, we begin at 372, and from that we're going to be subtracting, every single second is going to be another 15. So we're going to be subtracting 15t. So as the number of seconds increases, the amount that I'm subtracting from the 372 will decrease also. So 372 is going to get smaller and smaller as I move down. Next part says graph the function that you wrote in part A. So this is always a bit of a challenge when you look at a blank piece of graph paper like this. I'm going to put the origin here. So here, this point represents the height is 0 and time is 0. So I'm on the ground at that point, and time hasn't begun. The problem is that I don't begin on the ground. I begin 372 feet up in the air. So that means somewhere near the top up here, right, I need to be able to get to the number 372. So I need to scale this graph so that the top value, or somewhere near there, includes something near 400. And you look at it and you're like, well, I could probably, every 2 lines could be worth 100. So this could be 100. This would be 200 feet, this would be 300 feet, and this would be 400 feet. So if I'm looking at those, I'm going to start at about 372. So here's 350. 372 is just north of that, right? So I'm going to say this is a point on my graph, 372. Now, I need to go forward in time, and as time increases, right, as time goes this way, as time clicks along, the function is going to decrease some, right? I'm just sketching this in here. I know it's going to go down. So what I'm really kind of interested in is, well, how much time is it going to take for this to reach the bottom, right? How long will it take it so that the height is actually 0? And there's a pretty easy way I can answer that question, right? This function turns out gives me heights, right? In fact, the h of t is the height in terms of t. I could say, well, what if h of t is 0, right? What if that is 0, meaning I'm on the ground? So I'll just set it equal to the function. So 0 equals 372 minus 15t. So this will let me answer the question, hey, at what time t will I be down on the ground level? To solve this, there's a lot of things I can do. I'm going to choose to add 15t to both sides first. That gives me that 15t equals 372. And if I evaluate that on my calculator, so 372 divided by 15, off on my calculator I get a value of 24.8. So t equals 24.8. So what this is telling me is, in almost 25 seconds, right? In less than 25 seconds, I'll be on the ground. So I just need to make sure this is scaled out to include something close to 24. So if I look at it, I don't know, count by 5, 10, 15, 20. That's too little. Let's make every 2 worth 5. So this will be 5, 10, 15, 20. Right here is going to be, that's perfect. 5, 10, 15, 20, 25. Okay, so at time t equals 24.8, which is just shy of 25, I'm down at a height of 0. So this is another point on this graph. Well, with these 2 points, basically I'm set up to graph the whole thing. Let me just grab the kind of a straight edge here, put it down, and I'll just kind of go like, hey. Whee! There we go. So that's a pretty nice looking graph. I don't want to start Microsoft Word. That's a pretty nice looking graph. And I'll close Word, there we go, of what this function is looking like. Let's see what else we got here in terms of, there's more questions related to that. Let's see, estimate when the elevator is at a height of 200 feet. Well, that's when it's at a height of 200 feet. So basically, I'm looking here, here's 200. So when is this function, when is this line 200 feet going to hit this curve? And it hits right there. So if I come down, I'm like, when is this happening? Well, I know that this line right here is 10 seconds, right? So, and this line is 12.5 seconds. So it's somewhere around 11 seconds, right? About 11 seconds. So let's answer that question here. Estimate, let's see, at about 11 seconds, the height will be 200 feet. About, not, about 11 seconds. Maybe a little more, maybe a little less. Determine the exact time. Determine the exact time that the elevator is at a height of 200 feet. Oh, that's different. Let's see. To do that, I'm going to use the function, right? So the function, remember, was how I was using h, right? The height as a function of time is equal to 372 minus 15t. And we want to know when the height is 200. So I'm going to put this in. I'm going to say, hey, 200 is my height. My height equals my height. Look, this is crazy. What I'm saying here is my height equals my height, because this function gives me height. And this is the height I want. So the height equals the height. 200 equals, when is 200 the height of this function? So to solve that, we're going to subtract I'm going to subtract 372 from both sides. It's going to give me a negative number here, right? 372, and I subtract 200. No, I got, actually, yeah, we can't do it that way, can't we? 200 minus 372. Hey, it's okay to use a calculator. It's not at all necessary right here. But it's okay. So if you look at it, like, wait a minute, I got like 300. I'm going to take 200 away from that. And there's like 172. It's negative 172. I'm embarrassed I pushed any buttons. I'm sorry. So I get on the left-hand side negative 172, and on the other side it equals negative 15t. So to solve for t now, we're going to divide both sides by negative 15. And I get that t must equal, now that I want to calculate for, divided by 15. I get 11.46666. Let's see. Well, it's, t. I know it said exact, but I'm going to write like t is approximately 11.46, like that. Now I could turn this into a fraction too, math. Turn that into a fraction, and it says, well, that's funny. It's 172 over 15 seconds. Here's an exact answer. T equals 172 over 15 seconds. It's not seconds, seconds. So if this is the time, right, this function is going to produce exactly a height of 200. This is going to produce something very, very close to 200. All right, next question. Evaluate this function for a couple different values of x. So in each case here, we're going to be taking this functional value, and this is going to what's going to be fed into my function, and this function is going to produce a value and spit it out. So f of 6.2 equals 31.572 times my x value, 6.2, minus 17.741. I encourage you to, grab a calculator, check that out, evaluate it. But you should get something very close to f at 6.2 would equal, when I evaluate the right-hand side here, you should get 178.0054. Now, if f is negative 27.018, right, same sort of deal here. I'm going to take the 31.572, and I'm going to multiply that by this given x value, negative 27.018, and to that I'm going to subtract 17.741, and that gives me a value. And again, grab your calculator and practice that. Negative 870.753296. Number 5. Solve the inequality and graph the solution on the number line. Fabulous. This is not an absolute value inequality, it's just an inequality. I think I'm going to, I guess I'll use the distributive property first. I could, decide to divide both sides by -4 first, but I'm going to go ahead and distribute. So I'm going to multiply each of these terms inside of the parentheses by -4. So this is going to become -4 times x. And then -4 times 1 is going to be a minus of 4. And that has to be greater than or equal to 12. Adding 4 to both sides, we get -4x is greater than or equal to 16. And dividing both sides by 4, we get that x is, I'm dividing both sides by -4. And we've discussed, this a lot and why this is the case. But I almost forgot that if I'm dividing both sides by negative, I need to flip the direction of my inequality. So x's are less than or equal to -4. That's 16 divided by -4 is -4. Now, if I've got, on my number line here is a 0, 1, -1, -2, -3. Here's my -4. And it says it's less than or equal to that. So because it's or equal to it, I'm going to include that point with a nice solid dot. And it's going to be everything to the left of that. So all these values continuing. Those are the values of x that will make this inequality true. This inequality will always be true when I pick x from there, x values from there. Graph the compound inequality on the number line. It says x's are less than 4. Okay, x's are less than 4. Here's 4. And it says less than that, not or equal to. So no solid dot. In fact, I filled that in too much. It feels like it's a solid dot. X's are less than that. But x's are greater than or equal to -1. So here's -1. They can be -1, so I'm putting in a solid dot, and I'm going this direction. So x's are all those things that are in between these two, right? X's are the things that are greater than -1, and x's are the things that are less than 4. Last two questions. Number 7, evaluate each expression, show your work. So we have the expression, the absolute value of 4 minus 12. Well, this absolute value symbol is a grouping symbol. I need to figure out what's in the grouping symbol first. So I'm going to begin by evaluating the stuff that lives inside of it. 4 minus 12 is equal to negative 8. So this is the same thing as the absolute value of negative 8. And again, the absolute value just tells me the distance something is from the origin, from 0. So negative 8 is 8 units away. So the absolute value of negative 8 is an 8. That's my answer there. The next one's, what's the absolute value of 8 times 7? And again, the absolute value symbol, it's a grouping symbol, so I'm going to evaluate that first. Right? Negative 8 times 7 is negative 56. So this is the absolute value of negative 56. And when I evaluate that, the absolute value of negative 56 is 56. And our last question then, let me move up, is, oh, I've lost it. It's, where did that go? Get over here. There we go. That's it. Last question says, solves the absolute value equation. So in order to do this, I must consider the two cases, right? Either this is a positive 7 or this is a negative 7. It's one or the other. Either this is a positive 7 or it's a negative 7. Either it's positive or negative. So I'll write the positive case first. 2x minus 5 equals 7. So I'm saying that this, in this case, this was the positive. And the other one is, okay, let's say that it was the negative. So 2x minus 5 is the negative value, or the opposite of the other one. And that equals 7. Okay, I know a lot of you are just, you don't write this the way that I do, and that's okay. I just do this because of the what happens when we look at absolute value inequalities. But I think this is a nice way to look at it, so I'm going to stay consistent here. The left one, oh, by the way, this is equals 7, so those things that are joined with equals are always going to be or, so it's going to be either the value on the left here, or x can be the other one. This is positive, so if I distribute it, it doesn't change anything. So this is just 2x minus 5 equals 7. So adding 5 to both sides, I get that 2x equals the number 12. Dividing by 2, I get that x, although that looked like a 2 and it wasn't supposed to, x equals 6. That's one of my values. And the other value is I'm going to go ahead and multiply both sides of this by negative 1. That gives me that 2x minus 5 equals negative 7. Stop. Just a moment. Think about it. I just multiplied both sides by negative 1. If there was an inequality involved, I would be flipping the direction of the inequality. Turns out it's an equal sign. You flip it, it doesn't do anything. It's the same thing. So I multiply both sides by negative 1. Now I'm going to add 5 to both sides. That gives me that 2x equals a negative 2. And finally, I'm going to divide both sides by 2. So x equals negative 2 divided by 2, which is negative 1. So the two values that make this true are x is 6 and x is negative 1. Well, that's going to wrap it up. I encourage you to look at the extended practice sets we've had over the last couple days. There are several absolute value inequalities in those, and you're likely to see a couple of those on the test. I wish you well. I hope you do the absolute best, and I look forward to seeing you tomorrow. This is Mr. Roberts signing off.